Hello everyone, we are Alok Agrawal, working as an associate professor in the Department of Mechanical Engineering. I will be taking course internal combustion engine. So in that, one very important topic is valve timing diagram. In this video, we will see what is valve timing diagram. We will see ideal valve timing diagram and actual valve timing diagram. So let us start with what is valve timing diagram. Valve timing diagram is, or we can say valve timing is the regulation of the points in a cycle, in a complete cycle of IC engine, where the valves, that is inlet valve and outlet valve, are set to open or close. Means it will tell us when the inlet valve will open and when the inlet valve will close. Likewise, when the exhaust valve is open and exhaust valve is closed. So valve timing diagram give us this information. So there are two types of cycles that we have seen. One is ideal cycle and one is real cycle. So first, let us see what is the valve timing diagram for ideal cycle. In ideal cycle, what we considered that the valve, either it is inlet valve or exhaust valve, they both open and close at dead centers. Okay, so accordingly, the valve timing diagram will look like this. That is, see here IVO represent inlet valve open and IVC represent inlet valve closed. Similarly, EVO represent inlet exhaust valve open and EVC represent exhaust valve closed. So what is happening here? Here the valve are open and closed at dead center in case of ideal valve timing diagram. So in case of ideal cycle, when the piston is at top dead center, the inlet valve open, which is there, which can be seen within this figure. Once the inlet valve open when piston reaches top dead center, it will remain open throughout the suction stroke, and in that process, our crankshaft rotates around 180 degrees. Our crankshaft rotates by 180 degrees. So after the crankshaft rotation of 180 degrees, the inlet valve closes. So here the inlet valve opens at top dead center and the inlet valve closes at bottom dead center. Now once the suction stroke completes, inlet valve closes. In that case, both the valve are in closed position. Then the second stroke is compression stroke, which is seen by here. In this stroke, the inlet and the exhaust valve both remains in a closed position. And when the compression stroke ends, there is a ignition in case of a spark ignition engine, and there is a injection in case of CI engine. So at after the 180-degree revolution of crankshaft, what is happening? There is a sparking or fuel injection. And in ideal cycle, we consider that the complete mass of charge will burn when the piston is at top dead center. So here, when the piston is at top dead center, ignition took place, and at the same time, all the fuel will burn. After that, what is happening? There is a power stroke or expansion stroke. So in that case, what we are saying? We are saying that both the valves are again in closed position and piston moves from top dead center to bottom dead center. While moving top dead center to bottom dead center, the both the valves are remain in a open condition. Okay. In that case, when the piston reaches bottom dead center and the power stroke ends, after that the next stroke is exhaust stroke. So in that case, exhaust valve remain open. So when exhaust valve get open, it is when the piston is at bottom dead center. So here it is seeing that EVO, that is piston exhaust valve opens when the piston is at bottom dead center. And now it will remain open for another 180-degree revolution of crankshaft, and it close when the piston reaches top dead center. So in ideal cycle, what we are considering that the piston, the valve open and close at dead center. Means either it is top dead center or bottom dead center. And this phenomenon took place instantaneously. Means the opening and closing of valve is taking instantaneously. It is not taking any time. So we can see this in animation. So what is happening here? See, the piston is at bottom dead center, some valve open, and when the piston is at top dead center, again another valve open. So here it represents that in ideal cycle, the mechanism or the valve is opening and closing only at the dead center. But in actual cycle, the scenario is different. Here, the inlet and exhaust valve does not open and close at dead center. Why it is happening so? It is because of two factors. One is mechanical factor. What is there in mechanical factor? Here, uh, in actual, what is happening that there is a clearance between the valve, okay, the valve and the mechanism which is opening and closing of valve. So, opening and closing of valve is taking place with the help of cam mechanism. So, there is a clearance between the moving component, and because of that, the opening and closing of valve does not took place instantaneously. It will require some time, and if we'll say in terms of crankshaft degree, it will require some revolution of crankshaft. So, because of this mechanical factor, the valve are not set to open at dead center. But if we want our valve to open when the piston reaches top dead center or bottom dead center, so we have to start the mechanism of opening before it. So because of this mechanical factor, we need to consider that the inlet valve open and close or the exhaust valve open and close before some time. Okay, not in at the dead center. Another factor is dynamic factor. Dynamic factor, what is happening in dynamic factor? It is because of the inertia of the gas. See what is happening that the effect of gas is very important factor that need to be considered because when the gas is moving during the suction stroke, fresh charge is coming inside the cylinder. What is happening? It has some momentum. It has some inertia. So if we close the valve suddenly at dead center, what is happening? That inertia will tends to hit the inlet valve in case of suction stroke, and in case of exhaust stroke, we tend to hit the exhaust valve, and this will damage our valve. So to maximize, to get the maximum benefit of charge that is coming inside, and to take the maximum benefit of exhaust gas that need to be go out of the combustion chamber, we need to take this dynamic factor into account, and we need to delay the closing of inlet valve or closing of exhaust valve so that the maximum amount of charge can be taken inside the combustion chamber and the maximum amount of exhaust gas can be taken out of the combustion chamber. So these are the two factors because of which we cannot open and close our valve at dead center. So let us see what this actual valve timing diagram looks like. So first we will see for four-stroke engine. So what is happening here? That the inlet valve is not open at dead center, top dead center, but it will open 15 degree before top dead center. Similarly, inlet valve will remain open and will close around 30 degree after BDC. Okay, so the reason for this will be explained in next slide. Again, next, the exhaust valve will open 50 degree before the BDC. So exhaust valve, what we are opening it before 50 degree before BDC. And this will remain open and it will close around 20 degree after BDC. So it will be open for around 180 plus 20, 200 plus 50, 250 degree centigrade. Similarly, inlet valve will open for around, not around 180 degree, it will be open for around 25 degree. Okay. Now, there will be a valve overlap. In case of ideal cycle, there will not be any overlapping of valve. What is overlapping of valve means? For the same time, both valves are open. So in ideal cycle, one valve will close, then only the second valve will open. But in actual cycle, what is happening? There is a overlapping which is of 15 plus 20, 35 degree. So for this 35 degree, what we can see, there are both the valves are in open position. And in ideal cycle, we consider that ignition took place at TDC, but here the ignition took place before 35 degree TDC. Why it is happening? Because the fuel when ignite, it will take some time to burn. So our motto is when the piston starts its power stroke, at that time the fuel is completely burned and ready to give its thermal energy to the piston. So that is why we make it 35 degree before TDC. So let us see in detail why the opening and closing of valve taking place apart from TDC and PDC. So inlet valve open 15 degree before TDC. Why it is happening? So to ensure that the valve will be fully open and the fresh charge starts to come or starts to flow into the cylinder before the piston reaches TDC. Inlet valve closes 30 degree after BDC. It is because of ram effect, which says that when the piston moves out for suction stroke, the fresh charge is coming inside the combustion chamber. And when the piston reaches BDC and starts for compression stroke, because of the inertia of the fresh charge, what is happening? The charge continue to come inside the combustion chamber, and we want to take benefit of that. If we will close suddenly the inlet valve, what is happening? The charge will come and strike onto the inlet valve. So we'll give some time that because of its inertia or because of its momentum, the charge continue flow inside the combustion chamber so that maximum amount of charge can be taken inside the combustion chamber during the suction stroke. And we close this valve after some time when the piston start moving from TDC to TDC so that maximum amount of charge can be taken inside. Exhaust valve open before 50 degree. It is because to reduce the amount of work done during the process of exhaust stroke. See what is happening when we start opening the exhaust valve before piston reaches BDC during power stroke. The pressure inside the exhaust gas is high, which will be reduced when we open the exhaust valve earlier, and that low pressure exhaust gas will be going out during the exhaust stroke so that there will be less amount of work that we need to give to the during the exhaust stroke. So to reduce this uh, effect of work that we are giving during exhaust stroke, we need to open it before the piston reaches BDC. Next, it will remain open when the piston reaches TDC, and it will close after what the piston reaches TDC. Why it is happening? It is because the main aim is to take out the maximum amount of exhaust gas from the combustion chamber. So we will keep remain open the exhaust valve so that maximum amount of exhaust gas will go out of the combustion chamber so that there will be more space for fresh charge to come inside the combustion chamber. Now the ignition starts 35 degree before TDC. It is to initiate the combustion process before the power stroke will start so that the maximum fuel will be burned and the power stroke will be more effective. So these are the reason why the the valve will not open and close at dead center. Similarly, let us see the four stroke compression ignition valve timing diagram. Same thing here. The reason for opening and closing of the valve are same, but the change is only on the value of the degrees. Here the inlet valve open before 25 degree BDC. The inlet valve closed 25 degree after BDC, same because of ram effect. Exhaust valve also open before 50 degree BDC and closes 15 degree after TDC. There is a valve overlap of around 40 degree in this case, and fuel injection will start 5 degree before BDC. So the reason for such early opening and late closing of valve will be same as because of we have seen in spark ignition engine. So let us see the how this valve open and close. So this animation can tell you that when the piston is moving up for suction stroke, the piston will the valve will open before the piston reaches top dead center, and it will be like that. So it is not at top dead center or bottom dead center. The process of opening and closing will start much earlier than the dead center and much after than the dead center. This is all about valve timing diagram. Thank you. Thank you.